deep into the technology behind the rechargeable batteries that make EVs a possibility. You'll also be taught the basics of aerodynamic optimization and tire characterizations. As mentioned yesterday, all attendees today will receive an ISO certified acknowledgement of their participation, along with privileged access to study material and a recording of both sessions to help further your understanding. So please use them to the best of your ability. Lastly, there are several incentives awaiting the top performers at the end of today's session. So pay close attention and give it your best. Thank you. I hope all of you enjoyed this session. And now I hand over the session to the professionals from iPrime Skills. Over to you, sir. Sir, if you could begin the session. We're awaiting you.
Very good evening to everyone. Hope everybody's doing great. So we could start the second session now. I suppose my screen should be visible to you.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Right. Where were we? I think we were at Ackermann discussing the principles of Ackermann and end of yesterday's session, right? Right. Before getting started, quickly let me know whether my voice is clear and my screen is visible to everyone.
Yes, sir. It's clear.
It's clear, sir.
Yes. Great. So I think few of them had issue with understanding with Ackermann and how it's practically possible, right? So that part I tend to clear now because it's essentially it could not be directly intuitive if you are from anyway from first year and second year, right? So I'll add one more additional example. I think that could help you in a big way to understand it, right? So the basic understanding of Ackermann is this, that all four wheels should never have the same velocity, right? That's the overall agenda of doing it. So why we are doing it? All the four wheels in your car should never have a constant velocity or constant rotation when you're trying to turn it, right? So why is that? Why we are doing it, right? So now think of this way: all four wheels are spinning at the same rate. So when you're trying to turn it, they start fighting with each other, right? Because they don't have a similar curvature to follow, right? The one which is close to your turn. So if you're taking a right turn, your right tire is going to a very small circle compared to that to your outer tire, right? So that itself says that giving the same velocity to both tire is not a sensible idea, and that's why they discovered Ackermann, because that times take cars where people shifting from the early century cars, they were had a huge issue of slippage, right? So what's a big issue with the slippage is whatever the powertrain tend to produce, hardly you get 30% of efficiency, right? From that 30%, you could hardly manage a loss of 10% from the transmission through your gearbox, right? You already lost almost 10%, and when it comes to the wheels, by the time power comes from engine to the wheels, you hardly have 15% impact, right? This 15% somehow has to be utilized at the best, right? If your tire is slipping, all through your 15% is going nowhere, and that's the reason you never, all the whatever the entire department focuses, at last comes to this simple term: your tire should never slip, right? So that's all the design, dynamic stability, all factor comes into play once you have a non-slip tires or the tires not slipping at a higher rate, right? So to do that effectively, Ackermann helps us, right? By how? So now instead of giving a same angle of turn, you tend to give the inner tire more angle compared to that to your outer tire. Okay, so now whenever you take a left turn or right turn, try to closely watch any vehicles taking a turn. Your inner tire tends to take higher angle because it could easily finish the turn. Your outer tire takes slowly much more gradual angle, right? So that's how you avoid slippage. That's all about Ackermann. So it could vary anywhere between 60 to 70%, depend upon you're looking at sedan class or commercial package, different types of automobiles that you tend to see. But practically speaking, 100% is never possible. With that mechanical design, you could never make it 100%. So it's only for the picture that you see here is only for understanding. Practically, when you develop a product, you can't make this kind of designs. Right? So this principle of Ackermann holds and certain criteria for low speed. For low speed, your inner tire, depending upon which side you're taking a turn, has to have a higher angle compared to that to outer. But the whole concept gets reversed in a racing machine, because in racing machines you tend to increase the speed, which obviously increases the forces acting in it, right? So in racing machine, you shift the whole idea. Your outer tire should have higher angle turn compared to that to inner, because they have a lot of load transferring at the outer tire when taking a turn, right? So to get you much closer to the reality, think of this way. I know it's hard, but it's all the process of learning. What if you will have a reverse Ackermann, which is not practically possible, but hypothetically speaking, what to you'll have a reverse Ackermann in a commercial car? So what difference that it makes? So this answering this question, will lead you to the whole understanding of this subject or the point of context here, right? So if anybody could try, I'll give you a pause here before going to the next concept. What would happen if I'm going to put reverse Ackermann in your commercial car? What difference it makes?
Sir, if I were to try, I'd say that it would make a difference while handling the car normally, like while going in a straight line. A slight move in the steering wheel will lead to a large amount of turn in the car, right? So that's not desirable.
Okay, good. Somehow you tried it, appreciate it. So what will happen when you put reverse Ackermann in your commercial car is, now by far people driving it, they're so comfortable with the car because they know the steering is much giving a light load to the driver. But when you put a reverse Ackermann, that's not the case. In reverse Ackermann, your steering becomes too hard. That's why Formula drivers, they tend to train a lot on that, right? So that's the problem that you'll face. Your commercial car with reverse Ackermann, that's most popular interview question in the R&D. Your commercial car with reverse Ackermann will make the steering too rigid. Even for small maneuvering, you can't able to get the proper turn from your car. That's what happens when you misunderstand the concept. right? So moving on, two approaches here. One is the distance approach. It's straightforward. X is nothing but your the distance of where the Ackermann point is meeting, or the intersection point. WB is a wheelbase, right? So with respect to your wheelbase, where your Ackermann meets, so that ratio will give you how much percentage of Ackermann is, right? So if X is, I'll try to not it. Right? Yeah. So this is the distance of wheelbase from your wheel center. I hope it should be visible. Hold on for a second now. Yeah. So the whole idea is, if your intersection of your Ackermann is as same as the wheelbase, you tend to call that as 100%, which means that you have your Ackermann points here in this line of intersection. You could call that as 100%. If that's lesser, as we discussed earlier, if it is anyway in this region, that's, you're just decreasing the percentage of Ackermann, which is typical here, right? If you some way gone crazy with the simulation and you don't get the concept completely, you're trying to put your intersection point here, right? And remember, this intersection point is at instance, right? For understanding, we're talking about this here, but when we talk about dynamics, everything is changing. For this instance, this point could be here, anywhere here. For next instance, you can't imagine anywhere in the circle. It could be anywhere, right? But what your job being an engineer is, try to approximate the range it travels all through the wheel travel, right? So the whole idea, reverse it. So this is where your Ackermann lies. If it is, to make it very short, if it is in this quadrant, this positive quadrant, all that is Ackermann. Anything that comes this side, the whole design shifts. This is called a reverse Ackermann. So which means that you're shifting the whole idea that side of a vehicle, that is a reverse Ackermann, right? So or else you could use this modified approach, which is it's good for your first and understanding. The total turning radius is nothing but L divided by R, which is nothing but wheelbase divided by your radius of curvature, right? But when you go closer to the approximate, you tend to get a lot of data inside. But this is by far the best approach you could use to find what's your Ackermann percentage. So quickly about optimization, there are three ways to do it, or I should say, if you mess up this, your whole Ackermann goes crazy, right? One way of doing it is, as I told you initially, the tie rod outer ball joint, right? So this, yeah, what I mean by that is, this is what we call it as a rack, and this is the steering arm. This is the steering arm. So manage my writing. I'm not pretty sure of it exactly looks like here.
Sir, your text is not visible actually.
Okay. I think I've shared the entire screen. Let me see what I can do. I'll try to share the desktop. Which one works best? The desktop one or the window one? So I'll go with the screen this time. I'll share the screen now. What about now?
Yes, sir. Yes, sir.
Are you able to see my notations here?
Yes, sir.
Great. So this is a rack and you have a steering arm. What you call as a ball joints, usually, they come close to here, right? For simple understanding, could have ball joint at here, So in different geometry have different architecture, but I'll take one as a reference. So you have ball joints. This is your tie rod. Okay. So the idea is, by looking at the geometry itself without even understanding it, by looking at the geometry, you can say that this is Ackermann or not Ackermann, or this is completely reverse, right? So how that you can do it is, let us everything. Go back. So look at the geometry. I can be so sure that this particular geometry is something, right? But I know what it is, but you give it a try. By looking at the geometry or the layout itself, you can say that this is this geometry, or you could say, to make it the question simple, the angle is 90. This is 90 degree and this is 120 degree, which is more than 90, right? So anybody just give a try. What is what? Which is Ackermann and which is not Ackermann, which is reverse Ackermann. If possible, you could see it and just give a try. If you're not sure, that's fine. Because earlier this was more theoretical, but now you're getting into the design itself, right? Anyone?
Just a second, sir.
So can you repeat your question?
So by looking at the geometry 1 and geometry 2, I want you to conclude what kind of a geometry it is, whether it's a Ackermann or reverse Ackermann or a percentage Ackermann.
The second one is reverse Ackermann, and the first one is I guess the first one is
Okay, so you tend to say this one is reverse.
Second one is reverse, and so first one I need to think.
Good. So that's a good try. So look at it. How we can be sure is you're trying to convert your concept and trying to apply it. That's where learning comes in, right? Look at it. This is parallel Ackermann. The imagine of tie rod, that's what we are trying to intersect it. Like earlier diagram.
So second would be Ackermann, sir.
Exactly. So this is what called as parallel Ackermann, which means that your both tires, whenever you're trying to take a turn, they're always trying to have a common degree with them. If it is taking 5, this also seems to take 5 degree because they don't meet, right? Both have no intersection at all. But whereas in this case, this could be anyway near to perfect Ackermann because they're meeting it. So they could meet at rear axle depending upon the angle that you make it. They could meet anyway, right? So the whole geometry, if you reverse it, then you can call it as a reverse Ackermann, right? That's all the point that you can get from here.
So actually I took its geometry in some other way, so I got it reverse.
Yeah, I get it. So in your concept, in your understanding, if you want me to
yes, sir,
continue the same analogy here. So you'll have the reverse here. If the geometry looks like this,
Yes.
it means that it's reverse. But remember, with this axis, with this plane, you can still have reverse. But if you're going crazy on the angle, since if it is 90, it's what I call it as parallel. If it is anywhere greater than 90, I call it you're getting into Ackermann. And if it is less than 90, you can still make reverse Ackermann with having your axis this side, right? But since it's complicated, all the formula cars, you tend to see your steering geometry over that side, right? So this is behind and before, to put it in short. If you have a before, there is no way that you can make it Ackermann. It's very hard. Clear?
Yes, sir.
Yeah.
Yes,
So
sir.
moving on with the coordinate system, it's very important when you get a first-hand understanding of coordinate system, because the software use an ISO coordinate system. The book that you generally refer to, any vehicle dynamics theory book, they refer to different one, right? So you have to be very precise, because this could mess up the entire calculation that you're doing, right? So usually you have two coordinate system, vehicle fixed and earth fixed, right? So which means that where you're seeing from, are you seeing from inside the car, or is looking at the whole moment from inside the car, or is sitting in the road and trying to see the object, a car as an object, and see their motion, right? When you look into the car's perspective, we call it as a subsystem level approach. We are trying to look at all the components that contributes to this motions, right? So if your car rolls at x-axis, it's that motion is rolling, right? Typically happens in when you're trying to overload in the buses that you see, it happens in this direction. That moment is rolling, and you tend to brake, you get a motion, right? That is pitch, right? And you take a vertical motion. I could give an example: drifting. Somebody drifters the car. You're seeing from the top view, that motion is vertical. That's called as yaw. So it's yaw, pitch, and roll. So these are all highly targets that's given. If any irrespective of what level you get an entry in a company, this is a natural target that you tend to get. So how do you achieve it? You go to subsystem level. You start from spring, and all the components like suspension, roll bars, everybody has to be aligned to achieve this roll pitch gradient here. It's not the entire car's component, it's the subsystem component here, right? So now the coordinate system changes to the earth fix. So the difference being that is now we are changing the direction, right? So here, whatever you call it as, let me put it this way, your roll and your pitch, is it? And it's gonna be, yeah, right? So now what does the Euler angle does it is, it helps you with the conversion, right? So now no more your rotation, here it's given you, right? So rotation in yaw is been converted into pitch, right? So that's how your 3 Euler angle gets converted. So no more in the 3 is applicable when you do it in a software, right? So when you do it in a software, if in case a lot of software doesn't ask you earth fixed coordinate system, but it asks you what you have to do it is you have to only switch it, right? Means that your rotation is shifted to yaw, then in pitch. Okay, so you just want to replace this rotation to the pitch, and for the pitch you have to represent to the roll, right? You tend to only interchange these two. Okay, so for the rotation in yaw, you replace pitch, and then for pitch you tend to replace the roll. That's the difference in the coordinate system. Apart from it, the concept is same, only the way that you tend to denote the roll, pitch, yaw names slightly gets different, right? You have to adapt it for the tool that you're using, right? So when you're trying to model a suspension system, since we talked about the geometry, now it comes to the modeling. So this types of modeling is very famous in the academic, because it gets you all understanding of the car, right? So it's called as quarter car model, where you tend to minimize the number of degree of freedom, right? So you tend to have a 2 degree of freedom, one for sprung mass, all that whatever comes above the suspension system, and 1 degree of freedom from unsprung mass. So you're making a lot of assumption. That's why you're making this geometry, right? So what you tend to do is you assume your tire have a stiffness, because it's just a rubber, right? It's going to have a stiffness, and it's also have a damping property, and this is your mainspring. So this is your damper, and this is your sprung mass, which, like, what are the things that you could imagine that comes above the suspension system, be it chassis weight, passenger, goods, load, all that will be accounted. And whatever comes below the suspension system, tire, brakes, rotors, all that you could account for, right? So the whole point, what's the purpose of the simulation or modeling it, is to just get these values. What's the velocity of the body? What's the displacement that's been happening here? And what's the acceleration? This is the three main reason why you're modeling it, because once you get these three once you get the understanding of these three, you could entirely understand how it's going to behave with a given amount of vertical force, right? So to do that, you'll have one aspect. One is called a ride rate. So ride rate essentially tell you that how comfortable is your car is. So somebody, with a good experience, you can look at the ride numbers and conclude that this particular car is going to, feel so comfortable compared to that one another, right? So total ride rate is coming from the spring rate, how much of stiffness it's been given, and that to tire stiffness, right? So total ride rate, if you have a spring rate, is nothing but how stiffer your spring is, and your tire rate is also just a simple spring property, right? We assume that the entire tire is a spring, and we give all the stiffness values to that, right? So what I mean by stiffness is how much of force that you tend to give divided by the displacements being happening. So newtons per mm is the conventional unit. So this value will give you how much of ride happening in 1 quarter. Once you've done the all velocity, displacement, acceleration calculation, you could multiply to a half car, which is one segment of a car, right? So once you're done with the half car, you could interpolate the same thing to a full car, right? So why is that? Is solving a degree of freedom is extremely harder, right? So this model have only 2 degrees of freedom. We just doing it for 2 degrees. You can do the same model for even 1 degree of freedom. You could consider sprung mass and unsprung mass in 1 degree. The point being different is accuracy will be get decreased, and your simulation time is also decreased in 1 degree of freedom model. Whereas at 2 degree, it takes a lot of computational time to solve it. That's a big difference. Right, so moving on to the load transfer, it's extremely important that you get understanding that the load that the wheels experience are not always constant. They keep varying with respect to the acceleration, right? So as per natural law of physics, you tend to have mass and acceleration. The problem is that when you tend to brake your vehicle, a lot of load keeps shifting from the rear to the front, and it has to be limited, right? Because your front wheels are not so designed to take the load off, right? So what we usually set the target is 5% to 10% of load transfer should be greater than the rear, right? Whatever coming from the rear to the front when you're braking, it has to be anyway in this range, right? So similar when you're trying to turn the car or trying to do a drifting, your load transfer happening from the left wheel to right wheels should have this range of shifting, right? So for instance, usually the total overall weight of a commercial car will be say 2000 kg. If you have a 50-50 distribution, you'll have 1000 kg at the front, right? So that's a static condition, but when in dynamics, you tend to get a lot of load transfer, right? So it adds up another say 100 to 150 kg, right? So this will change the suspension parameters, like not suspension, the entire assembly here, right? Be it suspension, spring, everything has to be designed for the additional load, right? So you make sure whenever load transfer is happening, right? So you have to design 5 to 10% higher to get the desired output from your vehicle, right? That's the idea here. So getting deep into ride dynamics, because this is very essential when you tend to develop a commercial car, because commercial car is not bought for its handling abilities. It's only bought for the ride dynamics, right? So what is ride is, it's a very a simple term. Any vertical motion that you tire experience that the driver feels, right? So the relationship between your tire movement to the driver feels, it's called ride, simply, right? So your commercial car will have anywhere between 100 to 200 mm of vertical motion. That's how it's limited, right? So you could say that 100 mm is very low, right? The vertical motion of a car should be higher, right? That's where the catch is. If you increase the displacement of a tire, then you're obviously disturbing or de-isolating the passenger. So all the job that you're trying to do is trying to keep the tire as close as to the ground. I'll repeat once again. All the job that the engineer is trying to do is trying to keep the tire as close as to the ground so that it keeps maintaining the constant contact patch. Right? That's the whole idea. If it's 100 mm is reasonable. If it get increased, you tend to see your off-road cars are getting vertical displacement higher so that the driver getting disturbed a lot. Right? You don't want that to happen. So second is the 2G loading condition. What is 2G and 1G? Let me tell you that. You see an x-axis, it's just a wheel travel. Wheel is getting traveled. So if it is getting traveled this way, it means that it's getting the compression. Wheel is getting compressed. If it is getting the other way around, it is getting rebound, which is coming back, right? So at static condition, nothing is happening to the wheel. You tend to see that 6,000 newtons is a load that's being put on the wheel, and the stiffness that needs to maintain in the suspension system is 32.48 newtons per mm. If you don't have stiffness, you tend to see you're getting as close, you're getting your ground clearance very low. So you need 32.48 newtons per mm to support 6,000 newton in static condition. So this is called as (1G) loading condition. 1G is static. Whatever the design parameters that the company gives you or the supplier demands to have this much of property, your engineers will work on it and come up with a 1G loading condition. So what is 2G is double times of 1G, which is 12,000 newtons. So this is the maximum limit that your suspension can withstand, which means that, say, all of a sudden you hit a pothole, your suspension is getting a rapid compression and it's all the way rising up to 100 mm. As I told you, we'll have a plot near exactly at 100 mm. I'll draw it. So due to the rapid shoot, your entire suspension gets compressed and you get a maximum load to that particular tire as newtons, right? So this is what the 2G loading condition. So all the vehicle has to be designed up to 2G loading condition, because look at the travel here. Up to here, it's maintaining a linear relationship, which means that anything changing in x-axis will also change in y-axis. But post hitting at the 2G, you see it's entering to a non-linear division. Don't get confused with the term. What I mean by linear and non-linear is no more you have any effect on x-axis on y. So they're both independent now. That's what I mean by linear and non-linear, right? So this is what the linear zone. Zone 1 is linear, zone 1 is linear, and zone 2 you're getting into non-linear, which means that after 100 mm, whatever value that you tend to go, anything greater than 100 mm of displacement, everything suspension starts absorbing it. It doesn't allow the wheel to get displaced, right? It could be 150 mm if the wheel is trying to move. No, suspension is having a limiter. We call it as stopper. The stopper will not allow any more displacement after the prescribed travel of your suspension, right? Clear? So now how we are trying to achieve it, right? All that we are trying to do here, we tend to give a compliance. So compliance is opposite to stiffness. If you talk in terms of handling, you want the car to be so rigid and rugged. You talk in terms of stiffness, the car has to be so stiffer. But on the other hand, in drive dynamics, it essentially talking about compliance, which is nothing but a softness, how soft your vehicle is, right? So the more the softness that you tend to have, the better the isolation that your car is going to provide, right? So that's the whole idea. So as I told you, you can see here, Jones stopper, or anyway, different names. Jones bumper will limit the motion of your vehicle. Clear? So moving on, the model scalability, where you can start. I'll highly recommend you can start learning the Wataka. It's just a 2 degree of freedom. What you're going to solve? You're going to solve the equation of motion for one. So just you can randomly get an equation of motion and plug some values. You have a stiffness value, you have damping values, and you have a mass to it. Add a mass to it, and you'll have a 2 equation of motion, one from unsprung or sprung, right? So now what you'll have is you'll have a equation of motion in your hands for 2 masses. You'll have equation of motion for 2 masses. Now you want to simulate this and get the values of displacement velocity. So how we are going to do it? Now you want numerical methods coming into picture. So you can use numerical method. Basically, these are the method that the computer understands. It's a language that you tend to speak and trying to solve. So find a numerical method and convert your equation of motion into a numerical equation, right? And then incubate to a tool to get your final idea of velocity, displacement, and acceleration. Most of the time, the values are velocity and displacement. That will give you the whole picture. Acceleration is not mandatory, right? You can do the same thing in AFCAR, right? The only problem being it is you tend to increase the degree of freedom and you take a lot of time and money to solve it. That's why we start from quarter car and finish it in half car. A lot of time in India, we don't do it in full car. It's quite expensive. I've seen people who's running this simulation for 24, 25 hours, and it takes a lot of time to converge the simulation and get approximated result. Right? So handling. So all the part of riding is only focus on driver isolation and comfortness. On our other hand, we're trying to get into handling here, right? So handling majorly focus on how responsive is the car is. Is the car is behaving the way you want it to behave, right? So if it's getting played, I'll try to play this particular video. Okay. Okay, so the whole idea is if you're trying to steer through a corner, if the car goes away from your turn, that's understeer. If your car goes more than what you expected, it's called as oversteer. That's a short. It looks very simple, but to make the car always make understeer, right? Because you take any product in commercial package, every vehicle is designed for understeer. Because oversteer, nobody wants the vehicle to oversteer. They have to have a control to the vehicle. So in understeer, you have a lot of time and control to turn the car in the desired direction. But whereas in oversteer, you don't have too much of time. Driver gets panicked, and you end up in collapsing the car. So think of this way. If anybody could imagine, you have your car. Okay, you're trying to turn it and it's getting understeer. Okay, so is there any possibility without changing anything in the car, but still making understeer car to oversteer car in a very simple a layman understanding? Not don't need to be an engineer to make that happen. From a layman point of view, you have a car and it's taking a while to take a turn, and I don't know much.
So your voice is breaking.
Your voice is breaking. How about now? Is it clear?
Yes, sir.
Yes, it's clear. Yes. So what I was saying is, if you have an understeer vehicle, just have a automobile, and you don't have too much idea on it, or the engineering principle work, suspension design stuff. You want them to make your understeer car to right by a simple approach. You don't want to get too engineering on it. Is it possible?
Sir, by reducing the accelerator input.
You meant to say increasing the acceleration input?
I mean reducing slowly.
Reducing it. Okay. True.
So by reducing
Increase
some
the
aerodynamic drag and the
Yeah,
resistance
go ahead.
between the tires, we can do.
Okay. Any other answers? So it's very simple. Instead of having huge weight, that's the design here. Your engine is always placed at the front. If you have a front having a higher weight compared to that to the rear, your vehicle will start understeer. Right? Because the weight is high, the entire system gets stiffer. And on the other hand, if your rear is getting much weight compared to that to front, the distribution is higher at the rear, then it means that you tend to get oversteer, right? Because the rear stays very close and getting a higher grip, and your front loses the ability to sustain the turn, so you tend to get oversteer. So one easy way is add a lot of luggage load at the rear, in your car, and try to improve the load the times to that the front. Keep adding the load until your vehicle becomes oversteer. Right. So we come to the summary part of handling. So the whole handling point is that if your front is more compliant than the rear, your vehicle will always understeer. On the other hand, your in other words, to put it much simpler, you want to make sure which axle is stiffer, whether your front is stiffer or your rear is stiffer, right? So depending upon which is stiffer, your vehicle tends to get understeer, and vice versa. Your vehicle tend to get oversteer if your rear is more compliant, which means that if your rear is more softer than the front, you tend to get oversteer. So basically, it's all measured in degrees per G. How much of degree that you tend to take your vehicle, how much of load is getting shifted, right? So that I could explain it here. Think of this way. You tend to turn your car, right? So and your load is something like this. The lateral force is acting in this range. So I could tell you this is the load. Right? So what happens is at a static condition, you have 800 pounds of load, and when you're trying to shift the turn or trying to take a turn, due to the lateral force, you have additional amount of load being shifted to one wheel, right? So one wheel is moving to 1200, so another is moving to 400. That's the whole point here. So if one wheel is getting the load or one wheel is getting added, right, and another wheel loses the load, right? So the net lateral load transfer will get reduced down. Now look at it here. At lower, one wheel is experiencing different load transfer lateral force, another wheel is experiencing different lateral force. So the sum is getting decreased. That's the whole point. 680 is a total lateral force available at 800 pounds force, but since you sorry, it was 780, right? So this value here, look at it here. 780 was the lateral force available at 800 pounds of weight. Since due to the lateral shift, due to the vehicle is having a momentum, you tend to drop from there all the way up to 680. So your lateral force is getting decreased a lot, which means that there is a lot of chance that your vehicle getting instability, right? Because lateral force is nothing but the force that needs your vehicle to make stable, right? If you maintain that stability, you tend to, whatever your Audi performance that you tend to see, your sports car, racing machine, all the cars, they manage to come out of the corner as quick as possible, right? The only reason being it, the lateral forces are extremely higher, right? So they can handle a lot of lateral force, that thus their vehicles are much, much faster and quicker. Right? So that's the end of vehicle dynamics module. So I hope you guys are clear with it. Yeah, I'll pause here for a question before moving on to the next chapter. So this session will be divided into multiple parts. So we have upcoming speaker who tends to speak on the powertrain configuration and electric and plug-in hybrid technology as well, right? So I'll hand over soon to him. So before that, I'll complete one more module. I'll give you intro on hybrid and the design parameters so that he can continue with that, right? Yeah, so as we discussed earlier, there are different configuration for hybridness, starting from mild hybrid. You tend to see your Scorpios. All the Scorpio, they tend to have a small generator that supports the drive, right? I mean, if you are in, trying to stand in a signal, it senses that no more your vehicle is moving. It turns off it by itself without you trying to switch it off. It turns off by itself. So that vehicles comes in the classification of mild hybrid. So they don't feature electric drive. They're trying to assist the engine to not to get overloaded, because when you get overloaded, you tend to get so much of pollution over it, right? On a full hybrid electric vehicle, your electric drives are limited. It's limited in a limited range, probably 0 to 50 kilometer. That's where they are limited. In blended, intermediate, and e-reverse, you tend to see that they have a plug-in technology. No more your resource for getting the performance is getting compensated, right? So here you have a plug-in option. You have a wide range of different power configuration. You tend to get the best acceleration and the power option from your vehicle in these three categories. So in these three categories, you tend to get more power options available since they are plug-in. A wide range of options available for you, right? So here the power is much conserved, right? And finally, you have a full performance EV. So the whole demand is on the battery. So now the one segment of battery has to compensate for the performance, acceleration, torque, and still keep the vehicle's mileage in high end. That's why your model electric vehicle tends to adapt to different power configuration depending upon how much charge you tend to have. For instance, if your vehicle is getting below than 30%, no more you can't cruise it in high speed. It's trying to converge the entire system and come to a state where your power delivery is very limited. So usually we measure in terms of degree of hybridness, how much of power is coming from your electric motor and how much is compensated by your engines, right? So these values will give you overall idea that what kind of vehicle is that, right? Once you get the proportional understanding, you get the values here, right? So for micro hybrid, anything greater than 0.05 will be on that category, right? On the other hand, less than 0.1 or greater than 0.5 tends to say that parallel hybrid. You tend to use your both engine and motor to drive your wheels. You're not purely dependent on one powertrain. If you have the value 1, which means that you're putting the entire effort on motor and battery alone, right? So ZS is one vehicle which I'll strongly recommend you to go through it. So they have a 5-key standard which delivers all proof of resistance. They have extrusion, dust, fire, even all the road case, they managed to get a 3 to 4 star rating in Euro NCAP. They're still safest electric vehicle in the country, right? So after all predictions that they made, the product is still working fine and practically tested and proven. Euro NCAP was tested, I think, down the line 3 years back. They tested it and they certified that this is one of the safest electric car in India, right? So you could just check the specification and the configuration of this particular car. I think that will get you more on how they are integrated. And talking about the charging station, it's more of timing. They have already planned to start the AC fast chargers and DC superchargers. People who talk about lack of charging and time of charging, they are consecutive solutions for it. Already I think in Bangalore highways you tend to see a lot of charging stations where you can park your vehicle and tend to get charged. Meanwhile, you could watch a movie, or you could wait in the parking lot, right? So that is made available by NG, right? All the major cities that's connecting in India, you tend to see at least you'll have AC fast chargers or DC superchargers, right? So it comes with a car. You don't want to additionally pay or something, and even they give you home installed chargers, which means that if you buy a car, you get to use the charges or the technology that they provide, right? And the development areas, it is you want to understand where a lot of energy is going to be going into the development process. First is the cell chemistry, different amount of chemistry we are trying to come up with, because the conventional chemistry seems to no longer work for higher efficiency. Something like lead acid and lithium ion, they're trying to somehow get the high costliest minerals out of the league and trying to include new materials, so that you're still maintaining the battery cost optimal and not compensating on performance, right? And then you're going for a BMS. BMS just a doctor of the battery, make sure the temperature, voltage, currents are being regulated. If something goes wrong with the battery, it's the first intimation that you can get something wrong really with the battery, right? And you'll see the similar effect is going to go on power electronics, electric motor, and transmission. So why transmission is being the last part is that you need have a power, and then you try to conserve that power. Then you could think of the different wide range of options that you could have. Now you have enough power band. Now you can have a different gearing system, different transmission, and different mode of driving. Upward off. If you can't have that, obviously working on transmission will no longer lead you anywhere. So this is very important. As I told you in my previous session, one problem is selectivity. You tend to get a lot of non-renewable resources. Another problem is component, right? So what does the component means is the availability of battery resources, right? You tend to see here, this is the ingredients of lithium-ion batteries. You see magnesium, lithium-ion, cobalt, nickel, graphite, and so on, right? The problem is why your electric cars are so much costlier is because of the ingredients cost. If you somehow manage to drop it down, right, somehow decrease it, then you could see your electric vehicle cost is going down. And the one rare expensive product is a cobalt. So cobalt is the rarest mineral available in Earth, and it's quite expensive. And you look at the earlier mining data, huge amount of mining has been done in Chile, China, Australia, huge part, and very low part on these areas, right? So the dominant players in mining are China and Chile, and Australia, right? Which means that all the mining work that you're going to do on get the minerals from the third party people who are getting minerals, they're going to sell it in a high cost, right? So if India is going to get adapted to electric vehicle, one way is stop importing it, and start replacing the ingredients here, right? Because the as people tends to not buy here at 2021, very less people tends to move towards electrification. But think of 2030, where everybody wants to move towards electric vehicle, and now obviously you need more batteries to make electric cars. That time you tend to see this ingredients are getting too high in a price, so the engineers tend to somehow find a balance between replacing the cobalt. So I think two companies have started working on this. One is the Tata groups. I think they replaced they are still in the process to replace cobalt and use, I think, some plaster Paris to replace the component. Because what's the problem with cobalt is the shape of a battery that you tend to see, or the structural stiffness that you tend to get, is purely from the cobalt. If you remove the cobalt, you lose this structural integrity of the component, right? So use some plaster Paris and try to keep up the efficiency. So if you are an engineer, or even if you are pursuing your master degree, I strongly suggest to find this problem and try to replace cobalt with any amount of mineral, so that it still provides the same efficiency, doesn't decrease in any other performance of a battery. So these are the main players that you tend to see. The startups are the Ather, Sun Mobility, Ola Electric, and major OEMs are Tesla, Ford. I think our people know that. And suppliers companies are KPIT, Wipro. These are the supplier companies who tend to get the design and get it worked out. But end of the day, they don't want the product. The product are launched by the OEM companies, right? So these are divisions that you tend to see. A lot of software and hardware testing happens here. The two division in it. One is pure software. They tend to simulate all the data that's been given, and you're trying to interpret the value. On the other hand, it's hardware. All the software that you tend to get implemented in a hardware, and a lot of testing goes into it before getting the final product released. And when it comes to the division, it's a holistic approach to make an electric vehicle. It's not only electrical and mechanical. For the making up the batteries, you need understanding of chemical engineers into the picture, and algorithm for BMS and IoTs. That stuff comes from computer science. And mechanical, they only deal with the vehicle parts and designs, right? So, and then for electrical and electronic engineers, they work on the development of electronics system design, and then the integration, right? So these are the main areas they work on a subsystem level, right? Everybody works on a subsystem level. You wrap it out in every subsystem comes into picture. Once the chemical engineering is done from the battery, you tend to give it to your mechanical and electrical engineer, right? You tend to work on the design, integration and stuff, and then he moves to the final motor assembly, battery and power electronics. You need everybody into the picture to get the optimized value for it. Right, so that's the end of my module. I think the next instructor is ready.
Hello everyone. Yes, so Dr. Mallikarjun sir is going to handle the next session, and I'll be explaining you about the concept of your projects and the internship opportunity through us after the end of his session. So you have to wait for like another 1.5 hour. He's going to explain you about the hybrid electric vehicle, and after that we'll discuss on that point.
Thank you, Skill. Let me proceed now. Can I share my screen? Am I audible now?
Yes, sir, you are.
Yeah, yes, sir, you are audible.
Yes. Okay, thank you. Is it visible my screen now?
Yes, sir.
It's visible now? Okay. Yes, let me introduce myself to the team, entire team. Yes, myself, Mallikarjun Reddy, completed PhD from NIT Allahabad in powertrain systems, especially It was wind up by 2019. Later joined in Valeo R&D in Chennai. There I spent around 2 years in powertrain systems, especially as a hardware engineer in building blocks development team and as well as patents team. Then later on shifted to some other organization in Bangalore. It's going on especially regarding to the powertrain systems only. See, today I'm going to come across, especially regarding to the EV part. So means I can say it's more regarding to the hybrid part, especially integration with the battery as well as IC engine integrated with the battery and FC integrated with the battery. And also I will come across more regarding to the fuel cell hybrid electric vehicles. Then you can see wherever you want to stop me, you can stop me. Wherever you stuck to. Wherever you are not getting what I am going to convey to you, you can stop me. You can ask me wherever you want. But you can see why we need to study electric vehicles. This is my question actually. What is the purpose? Why we need to study? You see, if you see the electric vehicles compared to the say, if you see the progress of how it is evolution is happened compared from IC engine onwards. If you see, there is a lot of benefits in electric vehicles over the IC engines. See, IC engines, there is one more advantage, that is a conventional IC engines are there. In the conventional IC engines, there is a kick start is there, but it is going to take much time in EVs. In future, I think that is also we can overcome. Some major drawbacks in electric vehicles market, especially there are the 3 major drawbacks. One is range anxiety is there. Range anxiety means it is depending upon the battery charging. Suppose in previous, if it is suppose diesel engines, if it is a diesel or petrol, then we can fill the tank within 2 or 3 minutes. Full tank we can fill and we can move around depending upon the tank capacity. We can move 400 to 600 kilometers depending upon the tank capacity. But the same thing is not going to happen in the electric vehicles case. It's depending upon the charging condition, charging state of charge. So if you see, if suppose
Your voice is not audible.
Sir, you are not audible, sir.
I think sir is having some network issues. He'll rejoin in a couple of minutes. So I'll just wait.
Okay, everyone. So meanwhile, I'll explain you about the intensive opportunity that iPrime Skill is going to provide to the top performer of this workshop. So we'll be providing you one assignment tomorrow. Okay, because today you can have some revision. Tomorrow we'll provide you the assignment, and you'll be getting around 2 to 3 hours to submit it. The mostly assignment will be given tomorrow evening, so that you can complete it. Yeah. Hello.
Hello. Sorry for inconvenience.
Just a minute.
Hello.
Yes, sir.
Yes. Can I proceed now or?
Just a minute. I'll make you present. Yes, sir. Like you can proceed. Give me a 1 minute only.
Okay.
So we'll provide you the tomorrow evening assignment, and you'll be getting around 3 hours of time, and you have to submit it. And day after tomorrow, we'll release the result of that particular workshop. And the winner of the workshop will be getting some internship opportunity or the project work from our side in future. So that part also will let you know, okay, within 2-3 days, the result part. And apart from the project, some students having the doubt about the final year projects and the future opportunity. So that part also we discuss once the session is getting over, so that we'll have enough time without any kind of disturbance. We can discuss those points as well. All right, everyone. So continue your learning. Thank you so much.
Oh, can I proceed now?
Yes, sir.
Is it visible now?
Yes, sir.
Yes, sir.
Yes, yes. Yes, you see, I'm just talking about electric vehicles. You can see this major advantages by using electric vehicles. You can see, especially we came to electric vehicles. One is majorly we have to reduce the carbon footprints. That is one major thing. And also in future, if it is technology is mature enough mature, then we can go for this full electric vehicles. Till now, until 2030, as per my data, I think 2030 we can go for only hybrid electric vehicles. After 2030 only, there is a major share of full electric vehicles in the market. Then you can see this terms a table of content. You can see these are the topics I'm going to cover, especially regarding to motivation introduction, then types of fuel cells, and conventional converters. We about 5 conventional converters I will come across. Then drive also I will cover. Series, parallel hybrid electric vehicle, then complex. There are 6 drivetrains, conventional drivetrains are there. I will discuss about those conventional drivetrains. Then some startups which are existed in Bangalore and Hyderabad regarding to flying car sectors. Then you can see this motivation point of view. Then see why we used to study about fuel cells, fuel cell electric vehicles. See, yeah, actually this topic came into the picture in 18th century itself actually. So fuel cell means it's fuel cell energy means you can see it fuel cell hybrid electric vehicles. So fuel cell is integrated with the battery. That's why we can call it as a hybrid electric vehicle. In fuel cell means by using this hydrogen, we can generate electricity as well as water. That I will explain how we will derive it, how we will generate electricity as well as water simultaneously by using this hydrogen. Then if you see in the 18th century, there is enough mature technology is there in power generation, especially. In the power generation, actually people thought about whatever the researchers thought about to generate the electricity by using the FC rather than they push into the electric vehicle. That's why they thought to develop electricity by using this FC technology. In the time itself, in 18th century starting itself, there is enough mature technology by using this means conventional energy resources like thermal and this nuclear and all. Enough mature is there, and also there is a people aware about it. That's why they kept it backyard again this fuel cell. That is the one thing is happened in 18th century. But in mid of 19th century, in this Apollo satellite people, they kept this FC in Apollo satellite in 1960. It worked very well actually. They used it for 2 purposes. One is for water as well as electricity for the astronauts. Whoever travel in this Apollo satellite, they used alkaline fuel cell, AFC technology they have used in that to generate electricity as well as water for the astronauts. That is the point where they thought to keep in the transport sector also. Then you can see this introduction point of view. This if you compare the FC with the battery, there is a lot of advantages are there in FC compared to the battery. Suppose if you go with the battery electric vehicle, battery electric vehicle, it's depending upon the state of charge. See, if time is processing, then state of charge is going to decreases, and there is a dip in the voltage. There are 2 major drawbacks are there in battery electric vehicles compared to the FC. But in FC, that type of situations we cannot encounter in FC, because I will tell you it's similar to the IC engine, but we are not facing any means pollution and all that type of issues is not there. That's why mostly in Europe zone they started with the FCs in commercial sectors rather than in passenger sector. Passenger sector they haven't come yet because of cost issue. That's why they are still managing with the commercial sector only. They are in marine, they are in means semi trucks and rail and bus sectors. They are in those commercial sectors rather than the passenger sector. Then you can see this main point of view. It's a completely zero emission, I can say, but there is less than 2 to 3% impact is there in pollution. that too because of only heat is generated. So total three products are going to come out from the FC. One is majorly electricity, another one is water, and another one is the heat generated by the FC. That is the only one pollution. Other than that, there is no any pollutions compared to the IC engines. Then you can see this in future. I think after 2030, if you see the Ballard Power Systems, there's a famous means reputed organization is there in FC Technology. Its headquarters are in Canada. They used to supply FC technology throughout Europe. Actually, they are the leading firm in the FC technology. You can see it at Ballard Power Systems. You can see this is the you can understand clearly. If you see this is the single fuel cell. This is the structure is a single fuel cell structure. You can see this each and every fuel cell having the 7 layers are required. 7 layers are required. In that 7 layers, 3 layers are belonging to the anode section. These 3 layers are belonging to the cathode section. Center one is the membrane electrode assembly, MEA. See how it works actually. See, whatever the hydrogen is coming from this hydrogen reformer, the function of this bipolar plate is it has to collect this hydrogen and it has to push to the anode gas diffusion layer. This is the purpose of this bipolar plate. This is the bipolar plate. It has to collect the hydrogen and it has to push to the anode gas diffusion layer. In the anode gas diffusion layer, the purpose of anode gas diffusion layer, it has to collect from the reformer and it has to do some internal process here, anode gas diffusion layer, and it has to push to the carbon catalyst. In this carbon catalyst, what will happen finally? This hydrogen can break into the ions and electrons. It is done by the catalyst, anode carbon catalyst. This is a carbon catalyst. It will break this hydrogen into ions as well as electrons. Then if you see the property of this membrane electrode assembly, this is having the property which oppose the electrons and which allows the ions actually. This is higher conductivity for ions and worst conductivity for electrons. That's why electrons will repel and ions will pass through this membrane electrode assembly. Whatever the electrons is repelled from this layer and it will goes to outside the circuit. Then whatever the electrons is flowing through this outside circuit, then we can call it as electricity. Then you can keep on electrical appliance, we can see the impact in outside. This is we can call it as electricity. Then whatever the ions will go through the membrane electrode assembly, and whatever the electrons came from this outside, then again it will merge in this carbon catalyst layer. Carbon gas diffusion layer. There we can see the byproduct. Finally, we can see the byproducts are one is water. We can see the heat. Then we can see the electricity. Total three products are there. Then if you see entire fuel cell, this is a single fuel cell. 7 layers are there. 3 layers especially regarding to the anode and 3 layers are belonging to the cathode. If you see, this is I kept only 6 major fuel cells. I kept 3 under the means lower temperature and 3 under the higher temperature. I kept here. Then if you can see this actually, there are more than I think 120 plus types of FCs are there, fuel cells are there. That's majorly only 6 fuel cells people will discuss about it. That too, especially PEMFC, proton exchange membrane fuel cell. That fuel cell especially comes under the lower temperature. You can see this one. This is lower temperature. It can withstand until up to 150 degrees centigrade. That can suitable for the transportation sector. That's why most of the transportation sector people will use the PEMFC. And also you can see this. You can see the merits of FCs for PV and battery. So I already discussed about what are the merits of FCs over battery. If you can see this photovoltaic, I think it is highly depending upon the environmental conditions. We cannot make the vehicles by using this photovoltaic. It's very difficult to make the electric transportation sector. It's completely out of our transportation sector. We cannot make this PV, and also some people came up with the PV also, but it's very difficult right now. We can see in future it may come also. If you see compared to the battery, I already told you, FC's efficiency is somewhat lesser compared to the battery, but there is a lot of advantages are there. It's not depending upon the state of charge. It's similar to IC engine. If you fill the tank of petrol wherever you want, you can proceed. In the similar case, if you fill the hydrogen in the reformer, depending upon the reformer capacity, how much distance you want to go. It's more or less similar to the IC engine only, but the advantage is we can avoid this carbon footprints. Then you can see this types of fuel cells based on the membrane electrode uses. These are the 6 fuel cells, major fuel cells, which we can discuss in upcoming slides. Then you can see that this direct methanol fuel cell, DMFC, then PMFC, proton cell membrane fuel cell, alkaline fuel cell, and phosphorus acid fuel cell, PAFC, and MCFC and SOFC. You can see this clearly here. Characteristics are there. Each and every fuel cell characteristics are there. And here itself, I can tell you this direct methanol fuel cell means first 3 cells comes under the 1 minute. First 3 cells comes under the lower temperature, and the next 3 cells comes under the higher temperature. Then you can see characteristics point of view. Mostly this proton exchange membrane fuel cell is suitable for the transportation, and also this alkaline fuel cells also it can suitable for the transportation. This lower temperature fuel cells, it will up to 200 degrees centigrade. It can withstand. Then PAFC onwards, it is for a higher temperature. Then highest temperature it can withstand by the solid oxide fuel cell. It's around 1000 degrees centigrade. It's especially for the generation purpose. You can see this efficiencies and operation also, chemical reaction also. You can see this. This color band indicates for the lower temperature. This color band indicates for the higher temperature. And also you can see the applications point of view. This direct methanol fuel cell especially used for the portable products, especially for battery chargers and all. And also scratch pads also we can use this direct methanol fuel cells. Especially for transportation, we can proceed for the proton exchange membrane fuel cell. And also for space applications, we'll use this alkaline fuel cells we can use for space applications. Then production purpose and electricity generation purpose, we can go MCFC and SOFC. Then see, this is the structure. You can see elaborately. This is the direct methanol fuel cell, DMFC structure. This is similar, actually, what I discussed about in starting slide regarding to the FC structure. This every cell is having the 7 layers. This depending upon the input, then we can change this. But in MCFC and SOFC, we can proceed for the only 5 layers. There, because it is operating at very high temperature, we can avoid this carbon catalyst both side, anode side and cathode side. We can avoid it. Then this is suitable for up to only means lower wattage. I can say it is only less than 100 to 150 suitable. Then you can see this is proton exchange fuel cell. It can withstand up to 140 degrees centigrade. Then it is suitable. Because of this temperature range, it can withstand up to 140 degrees centigrade. That way, especially for commercial sectors, people are using this PMFC now. Then this is, you can see this alkaline fuel cell. In alkaline fuel cell also, this is especially for space applications. It can withstand up to 200 degrees centigrade. It was used in 1960. For both purposes, especially for water as well as electricity purposes. It's used in the Apollo satellite 1960, this alkaline fuel cell. Then this is also some other type of FC fuel cell, phosphorus acid fuel cell. This is also similar structure. You can see it. I think all are similar only, but if you see this MCFC, molten carbonate fuel cell, if we want to avoid these 2 layers, we can avoid this carbon catalyst from both cathode side. We can avoid because of higher temperature. This temperature itself can break this into ions and electrons. That's why we can avoid this 2 layers. The similar structure is happened in this solid oxide fuel cell. Then you can see this conventional unidirectional power converters used in the FC-HEVs. See, especially why I kept only conventional converters. You can see this buck converter, boost converter, buck boost converter, chip converter, and SEPIC converter. See, mostly we used to do a lot of research in power converter. But industry point of view, people mostly proceed with only boost converter, buck boost converter. That too, especially flyback, we can flyback converter and forward converter. It's another means isolated version of buck boost converter. We can call it as a flyback converter. Mostly industry proceed with the boost converter and flyback converter. That's why I want to discuss about it more regarding to these converters. Then you can see this. Especially for UG students, undergraduate students, if anybody wants to understand the converter, if you take any one converter, if you want to analyze it, you have to proceed with these fundamentals, 5 fundamentals. You have to understand it clearly. Suppose if you want to analyze any DC to DC converter, suppose let us take about a boost converter. If you want to analyze this boost converter clearly, you have to understand the 5 basic principles. See how to develop the voltage gain, how to develop the current gain, how to derive the current ripple, how to develop this voltage ripple. So there are five functions are there. If you come across this volt second concept, what is the volt second concept? Volt second concept means, suppose if you obviously if you take any converter, then you can find this filter concept. In that filter concept, then you can find this any inductors or capacitors. Suppose an inductor is there, if you see this fundamental one concept is that fundamental concept regarding to the say average voltage across an inductor over a period of cycle should be 0. By using that concept, you can derive this. You can develop this voltage gain concept. Means voltage gain you can develop means V out by V in. You can develop this one. Then by using this concept only, you can derive this voltage gain. Suppose in the similar way, if you want to develop this current gain also, charge balance concept. Charge balance concept means average current passing through the capacitor over a period of cycle should be 0. By using that concept, otherwise you will by using this power balance also you can develop it, because you already know the voltage gain and power balance is also similar. If you assume losses are 0, you can proceed with power balance. Input power equal to output power. By assuming the losses are 0, then you can develop this current gain by using that power balance also. And also power balance simultaneously we can use for the efficiency also. We can calculate, we can derive the efficiency formula by using this power balance concept. Then you can see this sub-cycle concept of inductor current. This means I think you can come across this for current ripple. If you want to develop the current ripple, output current ripple or input current ripple, whatever it is, if you want to develop this current ripple, you have to go with the sub-cycle concept of inductor current. You have to take the one cycle, whatever the current is, inductor current over a cycle you can take, and half cycle you can take it and you can develop this half cycle. If you take the half cycle, that too it is in steady state. And this cycle, whatever the cycle you are considering, that cycle should be in steady state, and then you can take the I min and I max, then you can develop this current ripple. Then in the similar way, you can proceed with the sub-cycle concept of capacitor voltage for voltage ripple also. This is you have to take this capacitor voltage of sub-cycle, half-cycle only you have to take in a steady state condition. Then you can develop this voltage ripple. If anybody understands this 5 concepts, you can analyze any converter in DC to DC converter section. Especially, I'm talking about DC to DC converters, especially from DC voltage to DC voltage. In that case, you can apply this one. And also sometimes it, I think first 3 it can come across in all converters, but last 2 it may not suitable in AC to DC converters. Then you can do this. Suppose if you go to if it is in DC to DC converters, if you come across this continuous operations, there is a major difference is there in rectifiers and DC to DC converters. Means DC to DC converters, continuous conduction and discontinuous conduction depending upon the current flowing in the inductors. It's not depending upon the current flowing in the load actually in DC to DC converters. In that case, in rectifiers, it's continuous conduction and discontinuous conduction depending upon current flowing in the load itself only. There is a 2 major differences are there. You can understand it while studying about rectifiers and DC to DC. Then you can see this briefly. I kept some points regarding to each and every section. You can see this is the buck converter. You can see this is the buck converter. Means you can see this. What will happen whenever the switch is going to off? Whenever the switch is going to off, then source current is continuous. Source current is discontinuous. I can say it's a pulsated current.
means a ripple current, ripple of this source current. Ripple of source current is 100%. Why? Means whenever switch is off, my source current is going to become a zero. My source current is going to become a zero. That's why I used to call it as a pulsated current. You can see this pulsated source current, 100% ripple content is there. But if you see this load current is not a pulsated. Load current is always continuous in DC to DC converters. This is the point what I want to make, a difference between DC to DC converters and rectifiers. In DC to DC converters, load current is always continuous. But in DC to DC converters, if you want to study continuous or discontinuous, discuss about this inductor. In this inductor, load current is not going to zero, then you can call it as a continuous conduction over a period of cycle. If it is going to zero over a period of cycle, then you can call it as a discontinuous conduction mode. Then that is the significant difference you can observe in DC to DC converters and rectifiers. Then you can see this in this we can buck the voltage. We cannot boost the voltage in this. Based upon this converter only, people have thought about to enhance the voltage. Its input voltage is suppose 10 volt. We can only make 9 volt. We cannot make here 11 volt by using this circuit. That's why again we have proceeded with the boost converter. You can see this boost converter. Suppose here 10 volt is there, we can make here 11 volt, but we cannot make here 9 volt. This is another drawback here. Here there is no bucking possibility here. Only boosting possibility is there here. And also, whatever the drawback is there in buck converter here, that drawback is we have avoided here. Means input current is here discontinuous. Here input current is continuous always. There is no, it is a continuous, but I cannot say it's 100%. Means there is no ripple. Ripple is there, but it should be less than 5% as per the IEEE standards. Then you can see this. It is always continuous in the input current. Whatever the drawback is there, that avoided here. And also load current is always continuous. But the drawback is here, one major drawback is that it is a non-minimum phase system. See, why it is non-minimum phase system? Non-minimum phase system means you can understand it clearly. Say, whenever switch is going to on, you can see it. Whenever switch is going to on, this diode is going to off. Then you can see this output is completely isolated from the input. Output is completely isolated from the input because this diode is going to off. In that case, output is no way regulated by the input. That's why we can call it as a non-minimum phase system. In non-minimum phase system, it is a more instability system compared to the buck converter. Buck converter is more stable compared to the boost converter. In this case, that is the one major drawback is there in this converter. To avoid this, and also another drawback is bucking possibility is not there. If you see, if you avoid this, whatever the demerits are there in buck converter and boost converter, we are proceeding with the buck boost converter. You can see this in buck boost converter. We have avoided whatever the drawbacks are there in buck converter and boost converter, but one more drawback is carry forwarded from the buck converter. See here again, source current is again pulsated. And we can by using this circuit, we can develop both bucking the circuit and boosting the circuit. We can have both the boosting operation and bucking operation. If we have 10 volt here, we can make here less than 10 volt and more than 10 volt. Both are possibilities are there. But another drawback came into the picture in this circuit. Output voltage is negative with respect to the positive. That is the major drawback in this buck boost converter. Output voltage is negative with respect to the input voltage. That is the major drawback in this buck boost converter. Then if you proceed with the Chuk converter, in the Chuk converter, we have avoided all the drawbacks which are existed in the previous converters. Here input current is continuous, output current is also continuous, and also both possibilities are there, bucking and boosting. But whatever the drawback is there in the output voltage is negative with respect to the source voltage, same is carry forward in this also. Here output voltage is negative, still negative with respect to the source voltage. Then if you go with this SEPIC converter, you can understand it clearly. If you see the circuit, if you see the circuit, this diode is in this direction. The current is flowing in this direction rather than down to top. Then here output voltage is also positive with respect to the source voltage, and also source current is continuous and load current is also continuous. Both possibilities are there, but drawbacks are there. It is a complex circuit, more number of passive components are there, and it's a complex circuit, and also we have to maintain it, this ripple current, input ripple current and output ripple current well within the 5%. That is the challenge in this SEPIC converter. Then you can see these are the brief introduction regarding to this conventional converters. Then we can see this types of topologies used in the drivetrains. You can see these are the 6 major drivetrains people used to study about it. There's a battery electric vehicle, series hybrid electric vehicle, parallel hybrid electric vehicle, series parallel hybrid electric vehicle, complex hybrid electric vehicle, and full cell hybrid electric vehicle. So elaborately, we can discuss about FC hybrid electric vehicle. Briefly, we will touch about this five drivetrains. You can see this battery electric vehicle. This is the structure of battery electric vehicle. This battery pack is integrated with the ultra capacitor to enhance this vehicle. You can see this. This is especially for the 3-wheelers. I can say it is for 3-wheelers, and nowadays Tesla is started with 4-wheeler also. But it's a very complex system. Battery pack is a 400 volt or 800 volt battery pack is there in Tesla cars. Then you can see this. This is conventional battery electric vehicles. In upcoming, they will go with the lithium-ion batteries rather than this lead-acid batteries. In Tesla, they used to go with the lithium-ion, small lithium-ion. Each lithium-ion, it can contribute around 0.7 volt to 1.1 volt. If you want to develop this 800 volt, you have to big battery pack is needed. That is the major drawback in this Tesla cars. Then you can see this series hybrid electric vehicles. This is the structure of series hybrid electric vehicle. If you see this structure, you can understand what is the major drawback in this one. It's a powertrain system. It's a too lengthy powertrain system, and also a lot of stages are there, power conversion stages. That is the major drawback in this series hybrid electric vehicle. A lot of losses are there. A lot of conversion losses are there. That's why efficiency of this topology is very less compared to the other topologies. And this is especially for the commercial sectors. This application we can use for the commercial sector rather than the passenger sector. Then you can see this parallel hybrid electric vehicle. This mostly this parallel hybrid electric vehicle people used to choose for the passenger sector. It is for the city drive applications. Here conversion stages are very less and efficiency is very high. You can see this directly in the internal combustion engine directly coupled with the chassis section. I can say it is in front of chassis section torque coupler. Then you can see this battery is connected to the torque coupler by using this inverter and traction machine. There is no much conversion stages compared to the series hybrid electric vehicle. Then you can see this, if you can understand this operation is very simple. If you see this series hybrid vehicle, this is internal combustion engine, then it will go to the rectifier, then rectifier it will feed to the inverter section. There here after rectifier it will go to the DC to DC bus bar, then DC to DC bus bar is integrated with the battery pack. This is the operation, you can understand it clearly. Then you can see this operation point of view, lower state of charge. Lower state of charge, this is the operation. Higher state of charge, operation. Why it is higher state of charge? If battery is fully charged, we can proceed with this we can use this battery energy rather than the internal combustion engine. If it is a lower state of charge, we can proceed with the internal combustion engine. And also in starting up the vehicle, we can proceed with this internal combustion engine. Then you can see this here also, working principle, you can see it clear. This is higher speeds, we can proceed with this internal combustion engine. And lower speeds we can proceed with the battery because of this battery electric vehicles. It can suitable for the lower speeds only rather than internal combustion engine. Then you can see this series parallel hybrid electric vehicle. This is the structure. Series parallel hybrid electric vehicle. This is the structure. You can see this is the combination of both series and parallel. So whatever the demerits are there in series hybrid electric vehicle and parallel hybrid electric vehicle, those all are wiped out here. You can see it clearly. So it is, but it is little complex. But a lot of advantages are there compared to series hybrid electrical and parallel hybrid electrical. This is electric intensive case and engine intensive case. This electric intensive case means if you say this is a battery pack, then energy is supplied to the chassis section completely in the electric case only. You can see this. This is a DC to DC inverter, then traction motor, then it will goes to the power split device. This is power split device. It's completely it's not a mechanical device. It's the electric device, power split device. Then it will goes to the torque coupler. Then it's rest of the system. That's how we can call it as an electric intensive case. Electric intensive case, we can use it after the vehicle is started. Then you can see this internal combustion engine case. This is the engine case. And this is completely we come from this is engine, then generator, then power splitter. That's why we can call it as an engine intensive case. Then suppose if it is in standstill also, we can charge the battery. You can see this how we will charge the battery. You can run this internal combustion engine and generator. Then we can whatever the energy is generated here, then we can put into the AC to DC. Then it can work as a rectifier. Then it will charge the battery. This is the path to charge the battery. This is the option is not available in previous topologies. This option is available here. Then you can see this complex hybrid electric vehicle. This is more or less similar to this parallel hybrid electric vehicle, but you can see this here compared to the series parallel hybrid electric vehicle. Here power split device is there, but here planetary gear system is there. In planetary gear system itself only, we directly integrated this internal combustion engine to cut the losses actually. That is a major advantage compared to the previous system. You can see here, but internal combustion system is there here, then again generator, then again power split system. It's a lengthy process there in powertrain, but that is here shortened here. Then you can see this fuel cell hybrid electric vehicles, FCEVs. This is a major topic which we are going to discuss it. This fuel cell hybrid electric vehicles, fuel cell hybrid electric vehicle, this fuel cell is integrated to the battery. Fuel cell is integrated to the battery at the DC bus bar. The rest of the system is similar. Then you can see this is the battery pack. This is the DC bus bar integrated to the DC bus bar through bidirectional DC to DC converter. This is as an interface. DC to DC converter is the interface between battery pack to the DC bus bar. Then you can see here similarly, this is fuel cell directly integrated to the DC bus bar, or it can integrate it to the DC bus bar through unidirectional DC to DC converter. Then this is the mostly why we need to study about FC, isolated FC and integrated FC. See, major drawback if you won't integrate this battery, if you won't integrate the battery and alone FC, if you want to run the vehicle, there is one issue is there cold start issue. Cold start issue means it will take much time compared to the IC engines. It will take much time to start the vehicle. Because of this internal process, rigorous internal process is there in fuel cell. That too, it will take. There are three major losses are there. One is activation losses. It will take much time to activate the fuel cell, and also ohmic losses are there, and also concentration losses are there. Three major losses are there. It will take much time to activate the FC. That's why that issue we can call it as a cold start issue. You can see this absence of storage capability. See, however, FC has following limitations. This don't have the storage capability. FC don't have the storage capability compared to the battery electric vehicles. That is the major drawback in FC vehicles, and also slower dynamics compared to the battery actually. Lesser dynamics, it will take much time. Because of this cold start issue only, slower dynamics compared to the battery. Then you see this. This is the architecture. You can see briefly. We can come across this one. This is FC architecture, and this is a fuel cell system integrated to the DC bus bar through unidirectional DC to DC converter. This is the battery integrated to the DC bus bar through DC to DC converter. This is DAB converter, dual active bridge isolated bidirectional DC to DC converter. Then you can see this. This is designed especially for the 1.4 kilowatt three-wheeler sector. 1.4 kilowatt, we can design it for three-wheelers. This is a DAB converter, dual active bridge isolated bidirectional DC to DC converter. Have a lot of advantages compared to the other converters. Okay, it can work for both bucking and boosting, and also if it is battery, if it want to supply the energy to the DC bus bar, it can boost the operation from left to right. It is boosting operation, and also a lot of advantages are there because of this type of topology. This is RDAB converter, means resonant to dual active bridge converter, having a lot of advantages like it is having higher efficiency and lesser losses, And also it can operate both soft switching, means ZVS, ZCS, both zero voltage switching and zero current switching is possibility, because in primary side we can develop this zero voltage switching by using this series resonance. And here also we can develop this series resonance. By using this series resonance, we can generate ZVS also in secondary side. But ZCS, if we want to develop ZCS, zero current switching, we can proceed with this parallel resonance in secondary side. Then you can see this is the full bits three level topology. This is especially if we want to keep this interface, if we want to keep this converter, there is a major drawback is going to happen to the FC system. Suppose if vehicle is in deceleration mode, whatever the ingress current is developed in this chassis section, it will come back to this DC bus bar. If it came back to DC bus bar, if there is no regulating mechanism like this unidirectional converter, it is going to damage to the FC directly. That's why we have to keep at any cost this FC interface, this unidirectional DC to DC converter. That is one purpose. Another purpose, it can regulate the terminal voltage of FC, because a lot of fluctuations are there in terminal voltage. It can vary from 54 volt to 80 volt in this 1.4 kilowatt system. That's why we have to use this unidirectional DC to DC converter to regulate up to 80 volt. Then you can see this modes of operations. These are the four major modes we will discuss about: this cold start mode, normal mode, acceleration mode, and deceleration mode. You can see this. This is the cold start mode. How it works in the cold start mode. This means in the cold start mode you can see the directions actually. So battery alone itself is going to run the vehicle actually. So we are not at all going to get any energy from the PEM, proton exchange membrane fuel cell. It will take much time because of this cold start impact. And due to this one only, we are going to run the vehicle by using this battery only. If there is no battery, if it is an isolated vehicle, it will take much time. This cold start mode, it will take much time. Then you can see this how it will works in cold start. You can see this whatever the current is coming from the unidirectional converter, it's completely zero in this state. Then in that condition is completely whatever the current is coming from the IBDC, means the bidirectional converter, it is going to supply the whole vehicle actually. Then whatever the voltage is built up across this DC bus bar, it's 120 volt system. It's you can see it is supplied by the only it is coming from the only this bidirectional DC to DC converter. Then you can see this normal mode. Normal mode means vehicle is in normal mode, completely supported by the PEM FC fuel cell. Vehicle can run by this fuel cell only. Simultaneously, it will charge the battery. It will charge the battery in normal mode. This is the operation of normal mode. Then you can see this. These are the characteristics of the normal mode condition. You can see this immediately battery current is going to negative. Obviously, it is going to charge mode. Then this rated current of this charging condition is around 3 amperes. Then you can see this unidirectional DC to DC converter. Its current is 10 amps. Rated current is 10 amps because it is in normal mode. Then you can see this bus voltage is fixed in this normal mode condition. Then you can see this acceleration mode. In acceleration mode, this is the working operation. In acceleration mode, both has to assist to the vehicle to get the required torque. If it is in uphill condition, its more torque is needed. In that condition, both battery and FC both has to assist to the vehicle. You can see that's why this power flow is going to supply to the chassis, and also FC is also supplied to the chassis. This is the condition. That's why you can see this both IUDC is also in positive, and this IBDC is also in positive. In this condition, at 0.1 seconds onwards, the batteries also start assisting the chassis, and also this whatever the energy is coming from the FC is also going to increase. Then obviously whatever the current is coming from this IBC, then huge torque is required, huge load is there in the vehicle. That's why there's a dip in the DC bus bar. This voltage dip is going to happen in this DC bus bar. You can see this. This is the deceleration mode where I talk about this energy storage. There is no storage in the FC. That's why there is no possibility to store it. That's why we have to keep in this unidirectional DC to DC converter to regulate it. Whatever the energy came from this chassis section, it has to store in the battery. This is the operation of deceleration mode. You can see it. Then this is simple actually. You can understand it. This is going to charge the battery. That's why it is in current is bidirectional current. Bidirectional converter current is negative. Then unidirectional current converter is 0 because there is no impact on this unidirectional current converter. Then you can see this. These are some aphorisms. It's not needed. Then you can see these are some of the startups in Bangalore. You can see this, especially regarding to this Mission Electric. And also Ola Electric, I think most of the people came across it. Ola Electric, they have started one plant, the biggest plant in world for two-wheeler sector, especially in Warsaw. It's per annum, they are going to produce 10 million two-wheelers. The startup production is already started in November itself. It's a giant company in two-wheeler sector, I can say. Then you can see it Ather Energy. They are also already production. They have, I think, released 3 to 4 versions in Ather. Then you can see this lithium urban technologies. They're mostly in this battery technologies. And Yuli also, Yuli is also there. It's a startup in Bangalore. It is in two-wheeler sector only. This is Bellatrix. You can see this Bellatrix is a good startup. I think most of the people came across it. It's, they have a tie-up with ISRO and they are developing good products, especially regarding to the aerospace sector. Then this is 3EV. They are going to develop this last mile connectivity vehicles, especially in three-wheelers. They have a good production. They have started production in Bangalore. They are going to supply for the Amazon itself. There's a Sun Mobility and Virya Mobility. They're mostly in this battery swapping technology, and also they're going to support the four-wheelers and this commercial sector as well. Then you can see some of the startups in Hyderabad. You can see this Godi Energy. This is a leading startup in Hyderabad. They are developing battery technologies, especially for lithium ion. It's a Palo Alto based startup. It's a US startup, but they have a branch in Hyderabad itself. So Mahesh Godi is the CEO of this organization. Then this Gaia Motor Works, and this is also there in three-wheelers as well as four-wheelers. They are supporting to them some tier 1 and tier 2 companies. Then you can see Race Energy. They are also in automotive. They used to develop this two-wheelers. They used to support to the two-wheelers. Then these are some of the organizations you can see. These are all of the startups companies in Hyderabad. Then you can see this, especially I want to talk about this sector. This is flying car sector. This is a flying car sector. It is an upcoming domain actually, upcoming sector. I think after 2025 there is a startup production is there in especially in German, especially regarding to the Lilium GmbH. This is a famous organization in the flying car sector. They are going to develop 5-seater flying cars and 12-seater flying cars. The purpose of this flying cars, there's a major impact is there in 2040 onwards. See, there is a statistics is there. You can see in the internet. This Lilium CEO is there. He has explained it very clearly. What is the impact of flying cars in cosmopolitan cities? If you see in future, actually, Bangalore city, if you see the diameter of Bangalore city, it's around now 70 kilometers. If you want to starting to ending, if you want to cross this 70 kilometers, in future it is going to by 2040 or 2050, 80% of populations are going to stay in the cosmopolitan cities. In that case, these cosmopolitan cities are going to become a 120 kilometers or 200 kilometers diameter. In that case, if you want to travel from one end to other end, there's a huge traffic is there. You cannot travel easily. In that case, this flying car sector is going to play a key role in 2040 onwards. That's why they started a lot of research in this flying car sector. You can see these are the listed companies in flying car sector. This is Lilium BH and Volocopter. These are the two leading firms in the world in flying car sector. Volocopter is in a German-based organization. Lilium is also in German-based organization. Vertical Aerospace, it's a UK-based organization. They are leading in the aerospace sector. Origin Aerospace, it is also a Swiss-based organization. They are also in the flying car sector. You can see this. These are the leading flying cars manufacturing companies in the world by 2025. Then you can see this. These are the some basic terminologies one has to understand. Whoever is studying undergraduate and post graduation, you can come across this one. It will helpful to enter into the automotive sector. One has to understand this HSI. HSI means hardware software integration. MHI means mechanical hardware integration. Then you can see this this terminology is key role. You can see if you want to, this has to understand the failure mode analysis. That means design failure mode effective analysis. This is started in aerospace. Now they are using in automotive also. Previously they used to analyze this DFMEA for aerospace, means for flying elements rather than the automotive. Now in automotive also you can understand this. And also most of the automotive companies, they will prefer this Symmetrix rather than the academic softwares like MATLAB and PSpice and all. They won't prefer, but Symmetrix they will prefer. Symmetrix have a lot of advantages. You can get the student version and you can try to understand it. There is a lot of chances to enter into the automotive by using these topics. Then you can see this. These are some of the companies in automotive sector. Then you can see this NV Technologies, ChargePoint, Lucid Motors. This is a leading organization in US actually. They have startup production already. They already released some of the cars in 4-wheeler sector. And also you can see this Tesla already. Everybody knows it. These are some of the leading organizations in the automotive. Then you can see this. This is also similar. Then these are some of the references, and this is the end of the presentation. If anybody wants to discuss with me, you can proceed now. Thanks for bearing me. If anybody have questions, you can raise it now. We can discuss it.
No, sir. No questions.
Thank you. Thank you. I'm just handing it to iSkill organizer. Can take care of it, man.
Thank you so much, sir. Okay, so like we were talking regarding the project.
Thank you. Thank you.
I had the doubt regarding the projects. So you may speak to me right now. Hello, everyone. I got a query from your coordinators. There are so many students who are having doubt regarding their projects. You may discuss with me if you want to develop a project, if you're working on that, if you want to get idea also. Mr. Srinivasan is also here, so you may ask these queries.
No, I'm not getting actually. You are asking me or what it is?
No, sir. From audience, sir, you may leave now. Thank you so much, sir.
Okay. Thank you. Can I leave now?
Yes, sir.
Presentation, sir. Both of the speakers' presentation.
Okay. Thank you. Thanks a lot.
So regarding the internship part, I already explained to you all. Okay. So now if you would like to discuss regarding the project part, you may ask one by one.
Participants, we were told that you had a lot of queries regarding the project work which was to be done and things like that. So if you have anything now, please unmute yourselves and ask or put it in the chat box. We'll wait for another 2 minutes. If there are no queries, we can wrap up.
I'll just give you some brief, okay, about the projects and all. So see, if you would like to understand about the project, what is project? So the project is nothing. It's just like some problem of the industry. You need to understand each and every technology required the development. Okay, not a single technology in the world is perfect. Each and every technology requires some part of development. So if you will be able to understand the technology which is available in the market, what all modification you can do over there, you can increase the efficiency, the performance, and the comfort, the ergonomics part, the efficiency, economical part also. So whatever thing you can improve in the product, that's kind of project for you. Okay, whatever things you are going to develop means that's called the innovation. If you would like to do any kind of innovation, then you need to understand the problem which is available in the market. Right. Hello. Please tell me. Is there someone speaking?
No, sir, you're audible.
Okay, so that's the one thing. Now, it's not only about the existing product. If you are having some curiosity and if you want to make something new also, then you can move for the domain of invention, which is like the product which is not available in the world. You may create a something like invention also. So it's all about your curiosity, the knowledge, understanding of the product, and also like how much you can think about the concept. Okay, so you have to just only work whatever you are going to learn related to electric vehicle. Electric vehicle is a vast subject. It's only the powertrain. Mr. Srinivasan, he speak about the concept of vehicle dynamics. So vehicle dynamics and all is one of the person that you need to understand. There are lots of development going on, and it will be going on till the last point. The electric vehicle may be like there's an endpoint for this. Like the IC engine, it was started somewhere, I think 1800, right? After that, now it's 2022 only. And you can find there's so many things which is about to evolve in the IC engine, right? So same thing you can consider this electric vehicle also. We can say like a 2050, 60, 70, or maybe okay up to 3000 era, right? After that, maybe like some other power source will be coming. So that part you need to just think about the product which is going on. You have to be like a future. You have to understand the people future need. So if you want to make yourself differ, if someone is going to ask me how to get a package of more than 30 LPA, 40 LPA in the mechanical sector, in the electrical sector, in the electronic sector, apart from IT sector, then that's the only way. That's the only way you can work on that kind of innovation, invention, and you can make your own startup, which can come like in the valuation of millions, billions, right? And you may also like share your invention, innovation with the company who are like a very, you can say friendly for accepting such kind of projects. So they can also give you a wonderful offer. So this is the way. Otherwise, if you want to just make something which your senior develop, okay, the people already developing in the market, that's called the ongoing trend. You're just going to follow the trend, nothing else. Even you guys are many are from mechanical. You can find the VIT. There's so many chapters. Some students they develop Formula One car. Some students they develop Baha buggy. Some students they develop the aero models. Some students they develop different products. But what they are trying to do, the people, I'm not talking about the VIT and IIT and another institute, but some institute, what they do, the senior were doing this thing, now they are also following the same trend. They are not worried about the further development in the product. They know like this is the process to welding, assembly, joining and all, and they are following it. So the best part, try to improve your technical knowledge because that is the must part. Okay, second thing, your curiosity, the learning skills, because it's very important. If you're going to stop yourself for learning, then you won't be able to develop anything. For any product, it requires lots of I'm sorry, it requires different branch of knowledge sometimes. Okay, and sometimes suppose you are a mechanical student, you are electrical student, you're going to develop one like a power electronics part, and for mounting of that power electronics you may require some like a knowledge of mechanical assemblies. So it's not always mandatory you go and learn everything from scratch. You may have like a request from someone who is from that background. You can provide them your assignment task like company does. Company is coming with a problem statement and they are giving that problem statement to their employees. Now the employees are working on that. They are providing the exact solution. So to solve the problem is very like easy. To find the problem is one of the difficult tasks in the world. Okay, to provide a solution, same thing is suppose you are having some kind of like a problem, health issues. Okay, so it takes like so many testings and all to get to know. Doctor will get to know about the exact problem. After that, They're having some predefined procedure. These are the like a medicine, these are the treatment they will provide you, and you will get recover. But the maximum time it takes when we are trying to find the problem. So now the best way is in a day you're going to interact with lots of product from daily use. Okay, from your mobile phone, from your laptop, from your headphone, everything you are going to see it requires development. So you can check what problem you are finding while using that product. You can check, and while learning something, suppose you were learning about the vehicle dynamics, you were learning about the vehicle, the people comfort. I'm sorry, I'm having some problem. Okay, so if you will talk about like the high speed cars and the expensive vehicles, so their high speed also means they're having wonderful which quality, riding or handling. The high speed car having which kind of quality, the riding quality or handling?
Riding.
Riding. uh, so what do you mean by riding? Can you explain me?
It is inclined more towards comfort and road compliance.
Right. Okay. So try to understand.
Cars are more focused towards handling, right? They need to handle high speed turns and stuff.
So you need to understand these 2 points. Both are correct. Okay. So if I'm talking about the riding quality of the product of the vehicle, it means you are looking for the comfort. And if you are having an expensive vehicle, definitely you want the comfort, but at the same time you want a wonderful traction also, right? High speed. In that case, you need to maintain the riding quality also. So riding and handling, if you're going to develop it somehow, both are inversely proportional. But this is the role of like a expensive engineer. I'll say the not the expensive company. It's an expensive engineer who is going to optimize both the parameters. To optimization is also one of the difficult tasks. The company who are developing this kind of product, the products are expensive. It's not because they're going to use very expensive components. It's one of the factor, but the second factor, the people who are developing these products are very expensive. Someone who is working in the Maruti Suzuki and someone who is working in the BMW at the same position, you can compare their salary range, right? So they have to manage these kind of things from the product only. So finally, if we are going to use the quality people, then we cannot sell the product at lower cost. We have to increase the cost of the product also. There are range of people who will accept this because they are working for their life to get the luxury features. So there's so many things. Okay, so you have to get a clear awareness about the project. Okay, project is something which is like a misguiding the people right now. Okay, when many students they're trying to learn lots of things, you don't have to learn everything. You have to just focus on one sector. Then only you can get the specialization. So if you want to get a job in the market, then you have to get the specialization. Without a specialization, you won't be able to apply it to the core company. You need to understand. IT company having very simple rule. They will come to your college, they will hire the bunch of people because they know they are going to provide training from very fundamental level. But when it comes to the core company, they look for the specialization. And you can get the specialization if you are going to focus since starting only on a very fundamental part of particular technology. If this is electric vehicle, now electric vehicle before to me, Malika Arjun sir was taking it for the power electronics part also. You can see there was so many heavy word. I was knowing you guys are not able to understand many factors because for him the level was different. He was even not knowing the audience. Okay, because this kind of technology required first thing the classification of audience. It's not for first year student. They cannot understand everything from scratch. So the power electronics is one of the domain. The vehicle dynamics is one of the domain. Then the vehicle simulation dynamics part is one of the domain. Then battery part is one of the domain. BMS is one of the domain. So there's so many domain integrated to develop the final product. So if you want to apply for any electric vehicle company, you cannot directly say you're electric vehicle design engineer. You need to tell them you're having the specialization in which part, whether the battery part, the BMS part, the power electronics part, the mechanical simulation, the mounting points, okay, the integration between mechanical and electrical part. So you have to be clear. So I hope you got some basic idea about the actual projects. Okay, so now you don't have to follow things that your seniors have designed. You don't have to just only participate in the competition. Just you are going to enjoy. You're going to participate in that part. You have to focus what innovation you are going to take in the competition. And in many competition, there are so many companies, they're like officers, they're technical officer, they come as a judge. So if they will find your innovation is like really up to the mark, you can get the offer directly from the competition. You don't have to wait for the company to visit your college, and you can get campus placement. So just find the right path, okay, work on the right quality of education, then only you can get the option. Otherwise, right now the market is very saturated. Even after the COVID, it is very much saturated. If you do not have a skill and if you don't have like a specialization, you won't be able to get the right job in the market. And even like we if I it comes to iPrime skill, so that's the actual work. iPrime skill is more into consultancy. We don't directly provide our trainings and courses. We comes with very limited courses, which is like a very specialized, the limited time also, because if I'll say it's a 90 hours of course, you have to enroll, it's 30 hours of course, I know no one is going to complete it, because if we are going to provide you everything from like a scratch, there will be lots of unwanted content. And the people who are really looking for the learning, they won't be like liking some unwanted content. They want something which is like up to the mark and point to point. So you have to find a way you can learn the things from books. Okay, you can find your own way to create your learning skills, and then only you can develop your project. So while learning only, you will get to know, okay, this is the like a battery, this company is facing the problem. Okay, so now what solution you can provide to them. So you can start development, and you can share the design with those companies through LinkedIn. Now you are having wonderful platform also to connect with a particular company directly officers, and you can share them. Okay, this is this is the problem in your existing product, and now I have designed this solution for you. So would you like to have a meeting with me, and I can present you the entire thing. You don't have to directly share it. You can have meeting, you can share with them. Otherwise, they may utilize your design also if it is like very beneficial for them. And then you can discuss with them about the terms and offer from their side. So there are so many ways. Okay, this is not like a one workshop and webinar we connected with you guys. We'll be like in touch with you all, okay, for a long term, okay, so that we can continuously, we can guide you, we can support you, whatever help you want from our side. And today there was one more speaker, Mr. Nandu, due to health issue, okay, he is not able to join. So for that, we don't want you to miss your learning opportunity. We are going to share you, okay, our like a previous webinar video on the battery and BMS part especially. Okay, that is around 1.5 hours of session. So I request you all, okay, after my like a meeting, okay, with you all, you have to watch that video today only, because maybe tomorrow the assignment will come from that part also. Okay, so you have to be aware. And now I request you all, you may interact with me. After that, I'll give you one of the like a one wonderful opportunity from iPrime Skill and VIT for you guys. So now you may ask me your queries, then we'll proceed further. As per my knowledge, the VIT students are very interactive. So what happened?
Hello, sir.
What's your
Sir, yeah, sir. First of all, thank you very much for such an informative session. And sir, like I want to know about the specializations that you are talking about. Like, which ones, like, which are like which have more trends in the future, upcoming future. Like, in which branches we should have specializations we can do.
Okay. So thank you, Ayush. Okay. So first, you need to understand, okay, your field of interest. If I use, I'll say you, okay, you learn graphic designing. Okay, you learn graphic designing, then people will think, okay, graphic designing means designing the posters and all. No, companies are going to work on the aesthetic of the product. Before like 2010, the people were like not worried about the aesthetic. Now everyone want to see the beautiful product in the market. So the car designers in the market, they are the graphic designer also. Okay, what they do, they create the sketch part, the sketching of the vehicle. They use lots of tools, lots of like drawings and all, the pencils, different colors, and they design it. In some of the country, there is specialization course also on the transportation design, where the people from graphic design background they join and they learn about it. And after that, they are getting a package of 20 to 30 LPA in the car sketching part. So you need to find in which field you are more interested. Suppose you are having more interest into only the electronics part, okay, then you can go into the power electronics part, because in by 2030 everything is going to drive by electric power only. When we are having the electric power means we require a system which is going to distribute these like a power from one point to another point. What was happening in IC engine? We had the fuel, okay, we were using the complete 100 cc engine, right? 100 cc means we had like that cylinder having the 100 cc volume. Now after filling the entire 100%, finally on the wheel, do you know exact how much the like power you were getting? It was between 20 to 30% only. The 70% power was getting lost. Where? During the combustion stage, then after during the power stroke, and during different losses. So on the wheel, the finally 20 to 30% power was like reaching. So same thing when it is electric vehicle, we are getting the power from the charging station, right? Charging station is going to provide the energy. It is going to enter in our battery. Then from battery, we are going to provide to different sectors, right? To motors also, to lights, different parts of there. So now, when you are going to transfer the electricity also, there will be huge losses from one point to another point. Just to manage these losses and all, we require the entire power electronics team, which is going to make wonderful circuit to which can avoid the losses, the different losses, different kind of losses that you will study whenever you are going to study about the power electronics. So this is like one of the domain. If you are like more interested about the battery, so that part I cannot like I say to you. First, you learn all about the concept and you try to feel in which domain you're finding yourself more comfortable. Then you learn that domain like anything. You try to learn each and everything about that domain and get the specialization. Become the scientist of that domain and get wonderful package from the industry. So you have to find your like your own interest. And now the training technology. Okay, if you will ask me the training technology, so there is no trending technology actually. There is always product. There is always product, and the product requires lots of technology which can develop it. If I'll say like electric vehicle is a product, this is in trending. Now the electric vehicle requires the knowledge and technology, battery technology, the BMS, power electronics, even the inverters, motors, many things it required. Same thing if I'll talk about the autonomous vehicle, then autonomous vehicle is again a product only. Autonomous vehicle is in trending. But to develop the autonomous vehicle, you need to learn data science, machine learning, the ROS part, integration of different sensors. If I'll say right now the trending is autonomous humanoid robot, which was used during COVID across the globe in many hospitals, hotels, airports, and different places. So now the humanoid robot is in trend. But to learn humanoid robot, you need to learn all the technologies which require to develop that humanoid robot. So technology is never the trend. It's all about the product which comes under the trend. And we need to check what all technologies required to develop that product. And you need to check in which technology you are more comfortable. You can get more and more knowledge. You can get more and more specialization to develop it. So you can pursue your direction. You can like apply all the effort to get into that part. You can see the example. And if you are at a like a particular position, once you want to enter in the industry, then only require the specialization. But after entering the industry, you can get like the specialization in multiple domain you can learn. But in the starting phase, if you will say to someone you know everything, no one is going to believe you, right? They will reject you. So don't take like any steps which can like provide you some negative impact.
Yeah, okay.
No query.
Sir,
Yes.
if someone is interested into ICE engine cars, so what are the possible unexplored domains for the future?
Yeah, wonderful question.
Yes, because every time all around we see electric vehicles, very little talk of ICE engines these days.
Okay, very good. Okay, so you can see like the research. Okay, at least this electric vehicle is not going to end very soon. It will be there in the market up to 2050 or 70 also. There is a possibility. According to research, by 2050, only 50% vehicles are going to convert into electric vehicle. So what about remaining 50? That also require the development, right? That also require the innovation. And now also it requires the innovation. And so the biggest challenge that companies are finding in the electric DICE engine, the one of the thing is the power loss. Okay. So if you can optimize the power losses and the power band also, the problem which we are finding because of the gearbox. So this is the like one of the sector where you can do research and development and you can optimize it. You can come up with like a wonderful design. So there are many like companies who are trying to work on this parameter. What happening actually? If they're trying to make the super bike, the high speed bikes and all cars, in that case they're getting very low efficiency. And if they are going to increase the efficiency, they can find they're not able to increase the top speed. So this is one of the point. So once you are going to learn something, then you can find what are the demerit of the things. That demerit only you have to improve. Demerits are kind of problems. So once you are going to learn the things, then only you will get to know what all problems are there and demerit of this particular concept. Then you have to think, you have to put your idea with proper designings, calculations, simulation, whatever things you can use, how I can improve it. If this is a demerit, then nothing is impossible, right? So definitely, if we can come up with like a sum of the design and prototype, that also like a company may call you for the presentation. I'll tell you one story. Okay, when I was in Pune in 2014, so that time like we were working on the braking system valve. There was like a one valve which can like a use in the trolley. Do you know tractor and trolley?
Yes, sir.
Do you know any company manufacture the trolley?
So Mahindra.
No, no one manufacture the trolley. They manufacture the tractor. Right? So if the trolley is not manufactured, okay, then who is going to provide the braking system in the trolley? No one was providing. No one was providing the braking system in that, and because of that, the many accident was happening. So we were working on that problem. We designed a valve, okay, which can integrate with the tractor braking system only, and can provide the braking to a trolley also. So we had a meeting with ARAI Pune, the Automotive Research Association, and we discussed over there about this problem and the solution. And the same day, like they approved our design, and they like with like they had discussion like with the union minister also, and they informed to all the companies if they are going to manufacture the tractor, then they need to provide a connectivity for the braking system in the trolley also. Otherwise, they are not allowed to manufacture the tractor. And that day, John Deere, Mahindra, and Mitsubishi, we had meeting with many companies who had purchased our design. So we haven't manufactured it like a product. We just came with a design, and we have said with like more than 7 to 8 tractor manufacturer company. So this is the only thing I told you. You have to find the problem. If you are able to find the problem, just try to design solution for that and give it to company. There are so many people who will accept you and will work with you on your product. You don't have to start like a manufacturing company, production company with so many of investment. No, you have to just come with a solution. People are there who will invest in you or who will collaborate with you for the investment, or who can hire you to work there as a senior design engineer or a good post like engineer. So this is one of factor. Okay, so we'll not do that much of delay. I think it's already getting late. So I'm going to provide you very first thing a video link Okay, you can go through it. It's a complete like a battery and BMS introduction, a great level, a very detailed part, 1.5 hour of session. You have to watch today only. So I'm like putting in the chat box. Okay, you can visit this link. Second good opportunity, like we are having one very optimized course on the battery and BMS using MATLAB simulation part, where you are going to work on like some part of machine learning also. You are going to learn on different like projects. I'll just share you, and that part also we are going to provide through VIT with very discount. Okay. EB battery and BMS design in simulation using MATLAB. In this part, you're going to work on MATLAB with a project on electric vehicle battery pack modeling using MATLAB, the BMS modeling and simulation using MATLAB, and the optimization concept also using machine learning. So now the machine learning engineers are also there in battery industry, where they're trying to optimize the codes and all factor which are required to optimize the battery management system. To solve these things, it's a more than 12 hour of course, and all the students will be getting international valid certificate for this course. Apart from that, letter of recommendation from our industry, the top performer of this particular course means who can submit their assignment on time, they will be getting the LOR also from our side. So many opportunity will be there. I'll share you the link. So now the course is like only 999, but for VIT student, you can use the code VIT 300 and you can get flat 300 off, which is valid only for 2 days. So this entire course you can get. It was designed in consultation with Ashok Leland. Okay, our like a design engineer, Mr. Nandu, who was supposed to take today's battery part. So I just sent you his link also. You can watch that webinar video also to get some idea about battery and BMS. So you can have like detailed designing session using this course on the battery and BMS using MATLAB. So this entire support like you can get it here. So this link also I'll drop in the chat box. You can visit. And you can use the code VIT300. So as I told, okay, you don't have to just learn everything. First, you can go through with all the concept, try to find your specialization, and then focus on the single part only, and learn from a concept. Try to learn maximum thing from book only. And if you're going to learn something, any course, online courses, then try to get some course which is optimized one. If you will like go through with course which having lots of content, okay, 30 hours, 60 hours, 90 hours of video, definitely you will leave the course in between that and you won't be able to get the final objective of the learning. So this is the best way. I know maybe like many of you are like opted course from Coursera, from like many platform. Just have a formal discussion with your friends and confirm with them how many of them completed the course without forwarding the videos. And you will get very low response. This was the research, okay, from like international body. Maximum 10 to 15% students are there who's able to complete the online courses with proper way. Otherwise, everyone is trying to forward the video. They're trying to complete the assignment to get the certificate. So this is not the error from the student side. This is the error of the online learning. Online learning is right now the copy paste concept. They don't know they don't have the knowledge of product. The best problem is because the industrial people who are working in the industry since last 10 to 12 years, they can only suggest what is the best way to learn particular technology, the concept, how to optimize it. And then the remaining thing in detail, you try to learn from books only. Because the people who are trying to like develop the video course and all, everything was designed from the books only, right? So it's better you go through a books, so I'll get like a reference of the wonderful books. I'll send you to Aviram some books also for the electric vehicle, which is internationally famous. Then he can provide you those links also. So this is the way, okay. And apart from that, you can have like a contact number, my contact number from Aviram. And if you're finding any problem in future regarding your job, your project, your placement, anything, You may contact me anytime. Okay, I can help you with any reference also. If you want reference in any of the industry, Mercedes, Valeo, BM, any companies from international to Indian market, I can help you to reach there.
All right then. With this, we come to the close of our electric vehicle design workshop. On behalf of ASME VIT, I would like to extend my deepest gratitude to iPrimeSkill for collaborating with us on this event. Thank you so very much for providing us with this amazing course and all the resources you've given us. Our sincerest thanks to all the speakers too for giving us such a comprehensive overview of such a vast topic over the past 2 days. It has been very informative, and I'm sure all the participants had a great learning experience. Next, I would like to thank everyone in the ASME chapter who worked so hard to make this event possible. Your efforts are much appreciated. Lastly, and most importantly, a big thank you to all the participants for taking the initiative and joining us for this workshop. You were a great audience, and we sincerely hope that the things you've learned here benefit you immensely in your future and your careers. With that, we wrap up this 2-day workshop. Please follow all ASME VIT social media handles and our website for event-related updates. Thank you once again, and have a spectacular evening.
Okay, thank you ASME team. And it's really a great team because I know you guys since last 2014. I'm associated somehow with ASME VIT chapter. So you guys are very active and you provide the right platform to the student to learn, to interact, to understand. So whatever support you can provide to your student, you always try to do that. It's really like appreciable from my end. So thank you everyone.
Thank you, sir.
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 Thank you,
Okay,
sir.
so good night everyone. And if you need any support, okay, you can get my contact number from Avi, and I'll be definitely available on the WhatsApp if I'm not able to pick your call. You can ping me anytime. So thank you so much.